Alright guys, let's do an example here for the derivatives of composite functions. So I have this crazy function here, x plus 5 over x minus 2 all to the power of 8, and I have to find the derivative of it. Now I wrote down the chain rule here on the side so we could refer to it, right? So if you have a function p of q of x, then the derivative is just going to be p prime q of x times q prime of x. We went over that in the slide in the video before. So we have this function. Obviously we're not going to expand this 8 times, but we can use the chain rule on it, right? Because notice how it's like a function. This x plus 5 over x minus 2 is like that q of x, and that function is within a big function to the power of 8, right? So our p of x is like x to the power of 8, and then our q of x is this function inside this x plus 5 over x minus 2. So, to get the derivative of it, let's first work with the outside function first, this function to the power of 8. So, whenever we have a function to the power of a number, what do we use? We use the power rule, right? So, we bring the 8 down. We rewrite the function inside, this x plus 5 over x minus 2. And then that is to the power of 7. Right? We minus 1 from the exponent. Now what we got to do is we got to multiply it by the derivative of this function inside. And notice how this function inside is a rational function, so we can use the quotient rule to get the derivative of it. So now we're going to be working with this function inside. So how do we find the derivative? Use the quotient rule. Quotient rule, you take the derivative of the numerator, so the derivative of the numerator is just 1, right, because of this x. So we got 1 times the denominator as itself, this x minus 2, minus the function up top as itself, this x plus 5, times the derivative of the denominator, which is just 1, all over x minus 2 squared. Right? So that's the quotient rule we just applied there. So if you don't remember it, you may want to go back and review it. So now what we can do, let's pretend like this 1 is in front here. So it's like a negative 1, and then let's distribute this negative 1 and this positive 1 in the brackets. So we could simplify that numerator. So let's rewrite this part here. So we got 8 x plus 5 over x minus 2 to the power of 7. And then we'll be left with x minus 2, right? Because you're just multiplying it by 1. And then distributing this negative 1 in, we'll get negative x minus 5 all over x minus 2 squared. And notice how in the numerator here these x's will cancel out, and then negative 2 minus 5 is just negative 7. So we end up with 8 x plus 5 over x minus 2 to the power. You know what, actually? I am going to rewrite this because we're going to simplify it more. I'm going to rewrite this as x plus 5 to the power of 7 over x minus 2 to the power of 7, right? Because basically any fraction to the power of x is just equal to the numerator to the power of x and the denominator to the power of x. So I just split them up here. You'll see why I did that in a second. So the x's here cancel out, negative 2 minus 5, that just ends up being negative 7 over x minus, sorry, this is x minus 2 squared. And now what we can do is we could just multiply all of the numerators, all of the denominators, and notice how these here are exponents with the same base. So you could just add the exponents when you multiply them. That's why I split it up here, because I knew this x minus 2 and this x minus 2 are going to have a common base, and we could simplify it even further. So negative 7 times 8 is negative 56 this x plus 5 to the power of 7, we just leave like this, over x minus 2 to the power of 7 times x minus 2 to the power of 2. That just ends up being x minus 2 to the power of 9, right? You just add the exponents there. And that is as simplified as we can get. So that here is our final answer. So right here, this is the derivative of this composite function here, right? So we just applied the chain rule. The outer function, basically our p of x was x to the power of 8, and our q of x was x plus 5 over x minus 2, right? If we're talking about this notation here. So I just applied the chain rule. So I did the outer function first, brought the 8 down, minus 1 from the exponent, right? Kept the inside function, the q of x, as itself, and then I took the derivative of q of x, this function inside, using the quotient rule, simplified it, and ended up with this answer right here. That's our final answer. That's the derivative.